Welcome everybody. Welcome to this afternoon session. My name is Klaus, and I will be talking to you about member functions and free functions. And I believe you've come here to find a definitive answer to this question. What should I use, free function or member function? What's better? Okay, spoiler alert, it's kind of in the title, but you want proof. Why should I do that? So, I kind of expect that there's three kinds of people in this room. So the first kind of people, they usually prefer member functions. So who of you who prefers member functions in general? Okay, that's about 50%. Member functions, yeah. Okay, free functions. Who prefers free functions? I'm sorry? Okay, so if you use both, you can raise your hand in both times. Yeah, of course. So about 50% free functions. Oh, this is going to be interesting. All right, and the third kind of people, that's all the people that are just here because they need some peace after 5 days of conference. They want to check the email. It's okay, I fully understand. If you accept you here, you're welcome to. We'll treat you well, no problem. So, believe it or not, this is a talk about software quality in general. So, I would have to ask you now, what do you think is good in software? What quality metrics should we strive for? Would take a little too long, and so I've selected a couple. And I just want to know from you whether you agree, and so we've hopefully found some common ground. So the first one is encapsulation. Who feels that encapsulation is something valuable, something that we should strive for? Okay, not everybody, interestingly, but this is probably the majority. All right, so second one, abstraction and polymorphism. Is this something good? Is this something that we should have? Who agrees? Okay, well, perhaps we have some common ground here. Cohesion. The things are following a certain principle. Okay, this is about 50%. Flexibility, extensibility. Oh, almost everybody. Reuse. Generality. Oh, again, almost everybody. Yeah, we have some common ground here. Testability. Okay. 90%, my guess. And performance. Okay, that's the ultimate argument for every C++ programmer, isn't it? We all want performance. All right, so I feel we have some common ground here. Now I'm bold. I go ahead and give you hypotheses, which I'm then trying to prove. An hypothesis is prefer non-member, non-friend functions. Okay, and I'll try to prove this point by point, item by item. First of all, however, I have to repeat the solid principle. So who has no idea about the solid principles, who's not heard about them before? Okay, awesome crowd. Even the cameraman knows about the solid principles. Okay, for you who have not heard about them, at least a short reminder. So in my courses, it usually takes me about 2 hours to cover them, but perhaps a short repetition doesn't hurt. So the first one, the S, is the single responsibility principle. This states that everything, classes, functions, etc., should have a single responsibility, a single purpose, a single task. It's a little difficult to explain because responsibility is a very vague thing, but at least you have an idea of what this is about. The O, the open-close principle. This is about being open for extension but closed for modification. Whenever you want to add something, add functionality, add classes and functions, at that time you should not have to modify existing code. In the optimal case, it's just adding, nothing else. The L is the list of substitution principle. This is about substitutability. You have a type, derived type, and you can use it where a point of reference to base type is required. It's not just about this technical issue, it's basically about contracts to base type. So deriving classes should adhere to the contract of the base type. Then the I, the interface segregation principle, gives you an idea that you should not have interfaces that impose a very high number of dependencies on somebody. You should segregate them, you should have minimal dependencies in interfaces. And the last one is the dependency inversion principle, which basically just says if you depend on something, you should if possible, own it. If you depend on an interface, you should own it, which is also applicable to templates. So if you define some kind of concept, you should, if possible, own it. All right. After this short repetition, which is truly just serving as a reminder, I have to prove my statement, my hypothesis. And the first item I give you is encapsulation. This is something that you might have heard. This is also why this hypothesis might sound familiar. This is something that Scott Myers wrote about, well, about 20 years ago. And this is the example used in Effective C++ 3rd edition, a web browser. And this web browser class has 3 functions. The first is called clear cache, second clear history, and remove cookies. So this is clear functions. And because it's 3, I want to have a convenience function, something that just clears everything, a clear everything function that calls these 3 other functions. And Scott is really adamant about this. This is not what you should do. This is not how the class should be defined. What you should have is a clear everything as a free function, which is, of course, a little different. It is past a reference to non-const and is calling the 3 public member functions. And he has good reason to argue this. So the argument is, clear everything on the left-hand side is a function that can do everything. It has full access rights. It can touch every single data member, even, of course, the private ones, which you definitely should have, of course. But it doesn't need this kind of responsibility. It doesn't need this. So pull it out of the class, and there's one function less that can actually potentially destroy invariance of the class. So this is good. This increases the encapsulation of the class. And I know that the worst thing that I can do is just read some text, but I feel this is actually a very, very good choice of words. So I'm doing it anyway. I read it. Object-oriented principles dictate that data and the functions that operate on them should be bundled together. And that suggests that the member function is the better choice. Unfortunately, this suggestion is incorrect. It's based on a misunderstanding of what being object-oriented means. Object-oriented principles dictate the data should be as encapsulated as possible. Counterintuitively, the member function actually yields less encapsulation than a non-member. I have to admit, I'm convinced. I'm fully convinced. This is a strong argument. But this is my personal opinion. And I've met many people who feel this is not particularly convincing. They don't like it. And so I have to better. I have to convince you differently. And so I come up with the second argument. Coupling. So you probably know, you're aware that dependencies and coupling are the prime enemy of our daily life. So we have to define or design software such that it minimizes coupling. Now let's have an example. I have a class X, and this class X has a vector of integers in the private section, of course. And this class needs to do something. Yeah, the usual do something function. But in this function, one of the first steps is I need to reset the values. All right, how do that? I add a member function. A private member function, this is an implementation detail after all. And in this function, I just reset all the integers to 0. So reset is not clear, as you see. Clear would mean I reset the size to 0, etc. Reset, when I say reset, I mean the size should stay exactly the same, but all the data, all the elements of the vector should be returned to the default state. Now, for an integer, this is just 0. This looks okay. However, there is something that we do not see. So how many dependencies do I have in the reset values function? Is it 1? Is it more than 1? Okay, tough question, I know. So there is something that we don't see, but this is actually a real dependency. That this pointer actually makes this function depending on class X. Yes, I need it because I internally access the values member. But is it really necessary? Is this truly something that I have to depend on? I would argue, actually, no. The only thing I have to do is I could add a free reset values function, a free function that is pass a vector to non-const, And in this function, I can do exactly the same. But how many dependencies do I have now? A single one. I'm only depending on vector. And this is even the beauty of it, this is actually better because I see it in the interface of the function. Before I didn't see it, but it was a private function, of course. So this is actually a real improvement. And still, I see in your eyes, you are not yet convinced. You're a difficult crowd, you know. So I have to do better. This actually also fulfills the single responsibility principle. So this is the first one of these solid principles, the basic object-oriented design principles. Why is that? Why does this adhere to SRP? In this form, X has a private member function that is doing a job. So it is apparently X's job to reset the values. But it is truly a kind of a service that X has to implement. Is this something that needs to be part of X? Not necessarily. This is something that I would argue could be an external service also. Less coupling, as I said. So, if you move the function outside, suddenly the real task of the class becomes clear. The task is not resetting values. The task is to do something. Yeah? And this is more obvious now. The class becomes better in terms of the single responsibility principle. And still, people are not looking like they're convinced, although it's the most important object-oriented design principle. I can do better. It also fulfills the open-close principle. So this actually gives me an enormous amount of flexibility and extensibility, which I'm going to prove. Have you ever tried in your career to, perhaps as a beginner, to add a member function to standard vector? Very likely you didn't, because it doesn't work. We all know that. This is not something that we can do. But you can always, and this is probably what you figured pretty early, add a free function to everything, whatever you want. It's always possible. I want to add a member function to standard vector, not possible. I want to add a free function, always possible. And this is exactly what I've done here. I have basically extended standard vector. The only possible way to do this is to add a free function. You don't look particularly happy, but this is actually amazing. This is so simple. Many people forget about this. Many people don't even consider it. But it's actually pretty easy to extend something, any type, by adding a free function. Did I convince anyone at this point? Okay, a couple of hands. Whew, this saves my self-esteem, you know. So, there's more arguments though, for those who are not yet convinced. Reuse, the dry principle. So dry, meaning don't repeat yourself. So, for just one example, assume that there is a second class. Yeah, I know, this is a little unrealistic now. Usually we, of course, only have one class and put all our stuff in this one class. But now for just this example, we have a second class. Class Y with also, coincidentally, a standard vector of integers in the private part. This one is called indices. And of course, else the example wouldn't be worth a lot, this vector of indices also needs to be reset. Now I need to reset all the indices to 0 for whatever reason. Isn't it beautiful that I don't have to code this again, perhaps as another private member function of Y, but that I can just use whatever service this reset values offers me? Okay, agreed. I have a vector of indices, the function is called reset values, not particularly beautiful. We can improve on that. We can simply rename the function. It's a reset function. Now it's resetting a vector of integers, whether this is values or indices, whatever you need, it is resetting this. This is amazing too. With just one free function, you've actually offered a service that anyone can use. And because it's a free function, anyone can call this. Wow. Actually, this is pretty cool. Again, many people forget about this. Still, there's people that don't believe me. I have to do better still. There's more. I'm now going the direction of polymorphism. Static polymorphism, of course. So usually my courses, when I ask a question, how does dynamic polymorphism work? What do people answer? Anyone? Virtual. The virtual keyword, right? The virtual keyword gives me dynamic polymorphism. And then I ask, okay, and how does static polymorphism work? Templates. So it doesn't take a second and somebody says templates. And then there's silence. Nobody knows what to say. And I say, and then people are confused. And what? Okay, CRTP, different topic. Now I have a second mechanism, function overloading. This is a static polymorphism mechanism too, which unfortunately is not properly used in many contexts. People don't use it because they forget about it. This is truly a tremendously powerful mechanism. And in combination with all the other stuff, amazing. So, what can I do in this function? Well, take a look at the red line. Value is equal to 0. This is not nice. As professional C++ programmers, we want to do better. So what can we do? We add a reset function. We add a reset function for integers. Yeah, I know, of course, we can improve on that too, but you get the point. Now, inside the function, I can reset all the values. Yeah? There's not an explicit I equals 0 anymore, but I just give this task to another function. So what does it mean to reset one of my elements? This is starting to be really beautiful. All right. Now, if you take a look at this code, there is an obvious next step. It's so obvious that probably nobody wants to say anything. What should we do now? Correct. Now I add generic programming. Of course, the solution was not particularly great. It was just for integers, but now I can improve on that. So I do it here in one case. I have a template, reset. This vector is of t, can be ints, can be doubles, can be strings, whatever. And I can reset all the values. What does it mean to reset a value? I can implement that. And I can implement this pretty well, pretty easily, because all I need to do is add a free function. You give me a type, a resettable type. You forget to add a reset function, no problem. I'll add it for you because I can. It's a free function. All I need to do is to add a free function. Okay, I don't know about you. I feel this is beautiful. If I would be a little better actor, I would now squeeze a little tear out of my eye and look amazed at this piece of beauty. Okay, you're a hot nut, you know. A pretty tough crowd. I still have to do better. Okay, here we go. So I mentioned this. This is actually an abstraction. Yeah, this is by adding reset functions. I have now created an abstraction, an additional layer of abstraction. This is what we are actually usually striving for. We want to make things simple. We want to start to understand complex stuff, and abstractions are just the way to go. By using all these fringe functions, we have actually created an abstraction layer that is pretty flexible, pretty amazing. Okay. Testability. Oh my, this is actually something that should be important to everybody in this room. We want to have software that is really perfectly testable. All right, let's go back to the first example. We have a private reset function. Yeah, I name it reset now, but we're good. How do I test this function? So, this was unfortunate to the silent that it didn't catch anything. There's multiple ways. So, type C++ testing private function in Google, and you will of course find at least one thread in Stack Overflow. And what are these guys suggesting? Always adding a friend. Who likes this approach? Almost no one, and I know why. This is awful. This is truly awful. You have now coupled your tests to your production code. This is exactly the wrong way. Now we have a two-way coupling. Tests to production code and, of course, production code to tests. Unfortunately, this is usually the right answer. So people click on, yeah, agreed, and this is what is solving the question. This is pretty unfortunate. Okay, at least for me, who does not like this? Okay, whew. So, but you've not seen the worst. Some guy afterwards says, oh, you can actually do better. Do this. Of course. So, the feedback gives me the point of you agreed that this is even more awful. Yeah, there is truly bottom point, and this is probably it. This is absolutely awful, and this is a clear indication that you have a design flaw. If you have a private function that you need to test, and you have to bend backwards to make it work, then something's wrong. You have missed something. Your design doesn't work. And of course, what is the obvious solution? Make it a free function. Pull it out of the class, make it a free function. So in general, perhaps it's not a proper free function, then at least make it a public function in another class that you can properly test. Please never use define private public. All right, so this is perfectly testable. I can always call it from anywhere. There is nothing I cannot not test about this function. So it's perfect. Wow. Okay, now who's convinced? Okay, many more people, because testing is important. This is actually how I get most people. But still, some people are pretty resistant. I don't like them. I don't like free functions. Okay, and so I have to go to the ultimate argument. The ultimate argument that I can give to every C++ programmer: performance. Okay, I know full well this is an argument that does not hold for everything, so not for every free function, but it does in many cases. And this is what I've learned at Meeting C++ in 2015 in a keynote by Chandler Carruth. And Chandler has to know, he is optimizing. Yeah? So he is in the optimizer team of the client compiler. And this is the example he used. On the left side, you see a struct. It's just a struct, there's nothing in the private part. There is some float values, x, y, and z, and there's a double value delta and a compute function, which returns another double. Okay. And then this struct is used in this fashion. I create an S, and then I, once after another, compute all these float values, and this is not a trivial computation, it takes some time. I don't know what it is. Then I compute this delta value, and then I call compute. And Chandler complained that this is something that client cannot perfectly optimize. And still he sees this frequently in performance-critical code. And this is why he actually gave this example, to tell people, why doesn't this work? What is in the way of the compiler that prevents it from doing proper optimization? There is a dependency. And we've seen it already today. Okay, I know, it's a tough question at the end of a conference. There is something we do not see, this pointer. The compute function is a member function. Because it is a member function, it had its implicit first argument, this pointer. This is an address, and there needs to be an address in order to call compute. So what client needs to do, and most probably all other compilers as well, is to create an S in memory, just that I can call the compute function. I need a valid this pointer. If this would not be, if there wouldn't be a this pointer, I actually don't need an S at all. I do not have to put anything in memory. This is just happening in the registers of the CPU. So by adding a member function to the compute function, you're actually preventing your compiler from doing the best he can do. As I said, this does not apply to everything, of course, but there is a couple of examples where this is actually really, really important. Okay, and with this argument, probably a lot of people are on board. Oh, if this can actually prevent perfect performance, I probably should better consider free functions. So by now I have almost everybody, right? Okay. Yeah, I know, it's tough. I forgive you. Okay. So this is what we should do, of course. So let's take a look again at a pretty extensive list of arguments. Encapsulation, the single responsibility principle, cohesion, flexibility, extensibility, reuse, so reusability, static polymorphism, generic programming, abstraction, testability, performance. If you're not impressed at this point, I basically have no idea what to do. This is virtually every argument in the book for what you should do, what you should have in your code. And I don't say that member functions do not have anything of this. No. Don't take me wrong. I just say free functions are better with regard to everything on this list. And it definitely should be a convincing argument. And still, I get the feeling there's resistance. No, I don't accept this message. Let's grab. And so a couple of clever guys come up with counter-arguments. You try to prove me wrong. Is this even a real idea? Is this used anywhere? Okay, good question. If it's just some vague idea that nobody uses, it's probably not worth a lot. However, I think I have a couple of strong arguments. What about the standard library? Oh, okay. So where? Well, for instance, let's take the standard begin function. You might have noticed that in C++11 they added free begin and end, and of course also cbegin and cend functions. These two functions, these four functions, complement, of course, the member functions. But they can do more. They can do much more. So this is the one that just calls the member begin, but look at this. This function, the third one, or labeled 2, this function is actually for static arrays. Static arrays don't have member functions, of course. But the free function actually gives me access to also these kinds of data types. Now what I want to do in my code, I would like to write std_begin. I don't want to write .begin. This makes my code more generic. It makes it applicable to more stuff. When you give me a container of whatever kind, and you missed to add a begin function, which is unfortunate, but it can happen, of course. The only thing I need to do is I need to write the begin function. I don't have to adapt my code anymore. This code is fixed. The code is done. I add something. I adhere to the open-close principle. That's actually really amazing. Okay, and this is probably worth a second example. std_real. If you work with complex numbers, which probably most of you don't, then you would ask, okay, how can I get the real part of a complex number? And there's a member function that you can call, but there's also, good thing, since C++11, a free function. So the free function for complex, so actually the new part is the one at the bottom. The real function is just a free function that gets me the real part of standard complex. That is not amazing. What is amazing, however, is the stuff that is here at the bottom, 2, 3, and 4. This is real functions that have been added in C++11 in order to enable me to write proper generic code. If I have complex numbers, it might also happen that I have floats and doubles, of course. I cannot call a float .real on a float or a double. The only thing I can do is I can call a free function. The standard provides me with these tools. This is exactly what it should be. This is what I would like to see everywhere. I want my code to be adaptable. I don't want to change it anymore. This is great. So yes, this idea is used in many places. In the standard library, in Boost, there's other libraries. These libraries actually give you the opportunity to do proper object-oriented and generic programming. Okay, some of you are still not convinced. So, you come up with another argument. Come on, this is just a reset function. This doesn't prove anything. Okay, I understand. I give you this point. This is truly just a reset function. It is pretty simple. I agree. I think the confusing thing is actually the implementation. So let's get rid of this. Let's just look at the function itself. The real question is not, does this prove something? The real question is, why does it work? Why is it giving me all these advantages? It works because reset fulfills two things. And this is actually really important things. First of all, it itself adheres to the singular responsibility principle. It does one thing, and one thing only. Because it does one thing and one thing only, I can give it a name. I can give it a clear, crisp name. Everybody knows what I mean. Because of that, I can start to overload. I can reuse it. There is something that I can do beyond just this being a function. So, the second thing is it has clear semantics. Yeah? And this is the key to every other argument. Overloading, making it a template, reuse. So if you do not, I turn it the other way around. If you do have functions that adhere to the SRP and have clear semantics, make them free functions. This is good. You will benefit from this in the long run. If you have functions, however, that do not adhere to these principles, okay, then this is probably functions that you should hide from the world. Put them in the private part of your class and be done with it. So this is probably not something that you will be able to reuse. This is not something that you can build on. Yeah, hide the ugly stuff, but enable the beautiful stuff. So, this is just a reset function. I don't really agree. So, no, this is not a counter-argument. Okay, I take it back. It is a reset function. It is not just a reset function, yeah? Okay. Functions should be encapsulated. Okay, also a good question. Isn't this about what object-oriented programming is about? Yeah? Encapsulation, the prime principle of object-oriented programming. And it is, right? The question is, should functions be encapsulated? Why is it that we encapsulate functions? What would be the rationale for that? I believe it's because we do not want anybody to call them. They do something that could, if used in the wrong way, could break invariants. This would not work, right? All right, but do I really have to put them in the private part of a class? Is this the only thing I can do? What about namespaces? Why don't you create a detail namespace, this is by the way what Boost does, and put all the implementation details, all the things that could actually accidentally do bad things, if you don't know what you're doing, in the detail namespace. It's a free function, it can overload, you can reuse it, it is testable. You have all the advantages. Nobody will call detail your function. I doubt that. I very much doubt that. So, I don't think that function encapsulation is really a thing. It is a lack of doing something that is better, or knowing about something that is better. Okay, I have another argument though. Let's go back to this initial example. Let's say we have now encapsulated the function in the private part. Okay, it's encapsulated. But actually, I can even encapsulate it stronger. I can encapsulate it stronger by first moving this function out of the class, make it a free function, and then move it into a CPP file. There is no mentioning of this function anymore in the header file. It doesn't have to. And the implementation of do something, which is of course also in the CPP file, can then use this function, this reset function, which is also implemented in the CPP file. This is even better from an encapsulation point of view, isn't it? This is perfect encapsulation. Yes, I truly agree. I'm convinced free functions are better for encapsulation. Okay. Some of you are inventive. Some of you have a couple of more things on your mind, so you know more, and you come with another argument. Oh, okay. No, this is not an argument. IDEs don't help with free functions, but with member functions. Okay, this must do the trick. Of course, IDEs don't help you with free functions, but if you have a string S, you can say S dot, and all the 170 whatever member functions are listed, and you can just select one. Okay, this is a strong counter-argument. Okay, so if you're Visual Studio users, it probably is, or any other IDE who uses an IDE that helps. It's a couple of people, and you would very likely argue my IDE only helps with member functions. This is actually a good point. This is something I cannot argue against. This is a reality. This is unfortunate. The basic thing what you have to do is go back to your vendor, yeah, Microsoft, JetBrains, whatever, and say, okay, look here, this guy told me I should add free functions. I want support in my IDE for that. Okay. The other alternative that you might have in the future somewhere is uniform call syntax. You might have heard about this. So there was a suggestion in 2014 that it should be irrelevant how you call a function. You should be able to say s dot call a function, which also calls free functions. And this is now a quote from Bjarne, who, I just read it. Note begin C and C begin for arrange for loops and in general code. Why do we, someone, have to write both? If C dot begin exists, begin C should find it, just as X plus Y finds the right implementation. In early 2014, Herbstadter and I independently decided to propose a unified syntax. To my surprise, many people came out strongly against X.fy finding F of X and Y, even if member functions were preferred over freestanding functions by the lookup rules. I received email accusing me of selling out the OO crowd. Oh my. So, I really hope that after the arguments I gave you, after I showed you the advantages that you get by free functions, you do not believe any longer that anybody is selling out the OO crowd. OO programming is not about putting everything to classes and hiding it up somewhere. There is definitely much, much more to it. And I believe that Bjarne was actually enabling the OO crowd. He was enabling them to do better things, to do more things. So this is pretty unfortunate. I know there's a lot of details that still need to be discussed. There's also a lot of reservations that how the lookup rules really should be. But if you would have it, then the problem of IDEs would be gone entirely. You could actually very easily work with free functions and your IDE would assist you. So, another argument that you might have. Programmers cannot find free functions as easily as member functions. Okay, also an absolutely valid argument. If you want to find functions, where do you look? You take a look at the class. Inside the class body, in the public part, there's all the functions that you can use. Where's the free functions? Could be anywhere. So this is actually also a good argument, but not an argument that is entirely impossible to solve. It's basically just a matter of how you structure your code. So now, go ahead, tell people This is a good thing. This is something that you should do. You should use free functions. And where do you put them? Well, one idea, just off the head of my mind, is to declare all free functions that are available directly after the class of a body. So if somebody wants to see what can I do with a class, he takes a look at the member functions and the free functions. He knows where to look for them. Of course, also documentation would help, but I know we don't document. So I believe this is just a matter of discipline, an agreement, for instance, within a company. Have a guideline. Where do I put my free functions? This is all it takes. So this is not an argument that can completely erase all of the good arguments, the good things that you gain. And still you're not satisfied. Oh my. In combination with ADL, free functions mean trouble. So who knows what ADL, oh, I turn it around, who doesn't know what ADL means? Okay, argument-dependent lookup. So you probably never wondered, but if you have a string and you use the output operator, it finds the operator. You don't say std output operator. It just finds the right function. It takes a look at that standard namespace and says, there it is. This is what I need. So this is ADL. And of course ADL, there's certain potential for trouble. You're absolutely right. I give you an example. Complex numbers again, I know. I'm a numeric guy. Complex number is a and b, and I say a dot min b. Does this compile? Okay, you don't use complex numbers. I realize that. No, it doesn't compile. Minimum is just not a relation that you can apply to complex numbers. What kind of minimum? That's not well defined. So, you get a compilation error. There is no member named min instead complex. Okay, now I change the example a little bit. I say min a and b. Does this compile? I'm sorry? So, is there an implementation is the question. Actually, there is. Std min, correct. The standard library has a min function. What are the arguments from which namespace? The standard namespace. So ADL goes ahead, takes a look at the standard namespace, and okay, there it is, min. We are lucky though, we get a different error message. And this says, so if you see the red part, the third line, return x smaller y, it complains the complex numbers do not have a less than relation. Whew, last second save. But it's not a particularly great save. It's not particularly great because it actually chooses the function. It just doesn't happen to compile. And this is the trouble that ADL can bring. This is true. However, again, the problem is not the free function. The problem is how I define the free function. Unfortunately, up to this date, min just takes anything. If you take a look at the signature of min, it takes a t. T can be anything. Yeah, so this can be used for really every single type. If, however, hopefully, eventually get concepts, this could be implemented by, I need a type that adheres to some less than comparable relation. And then this function wouldn't be selected anymore. So this is a weakness that we currently have in the language. But there is hope that this improves. And then, okay, free functions get just better. Hey. All right. So, this is not entirely true. Yes, there is some problems with it, but this is not your major concern or not your major problem, I believe. Are you satisfied? Who said no? Not yet? Okay, I know. You still have counter-arguments. I'm using virtual functions, so I cannot use this stuff anyway. Are you sure? So, let's assume that you have a virtual print function. And you would argue, well, no, I don't need a free function. I would say, well, probably you do, because you probably want to support the output operator. And the output operator is a free function. So, yes, this idea is still for you. But there's a suggestion. It's not something that you have to do, but this is also enabling other people to use your code. So use free functions in order to wrap virtual function calls and get a homogeneous interface. So you have other free functions, and then you have virtual functions. This is member functions. The interface is not homogeneous. Some are member functions, some are free functions. Enable people, make it easy for them. Wrap the virtual function in a free function call, and you have a homogeneous interface. This also might remind you about this idea of a non-virtual interface idiom. This is going in this direction. This is not bad. You might actually also gain from this. So even if you're using virtual functions, free functions are not completely off the table. In other words, you're not off the hook. Okay, and somebody is desperate. Oh my God, does this mean we should convert to functional programming? Okay, wait a second. Do you really know what functional programming is? So, is this functional programming? Is the reset function a proper implementation in the functional program concept? No, it's not. So it changes the vector. This is against the rules in functional programming. So do not be afraid. This is not functional programming. But you've actually made a very, very, very good point. This could be a function that is used in functional programming, if you rewrite it a little bit. So actually you have accidentally, of course, uncovered the bonus argument, pro free function. This is multi-paradigm. A free function is used in any paradigm. It's used in object-oriented programming, it's used in functional programming, it's used in procedural programming, whatever you have. If you use free functions, you could actually, you're enabling yourself to use all paradigms in combination. Whenever anything is, something is beneficial for you. This is great. It's just a small step between OO programming and functional programming. Just a little step. Wow. Okay, you're hard to impress. Really hard to impress. But I feel this is truly amazing. Okay, and now the obvious question. It had to come. Should we avoid member functions entirely? Okay. Do not go to Slack or any other social media platform and now quote me with, the guy told me I should not use member functions anymore. No, this is what I did not say. I did not say, please make all your functions free functions. What I basically tried to give you is a suggestion that free functions are very valuable for many, many of your functions. Several functions, however, cannot be good free functions. In case you're wondering how you should decide free functions or member function, take a look at standard vector. Standard vector has a lot of member functions. It's actually quite a number, more than 40. But all of these functions need to be member functions. All of these functions have some access to data members in the private part, or they modify them. They have to adhere to, they have to upkeep invariants. So all of them need to be member functions. But this is it. Apart from that, there is nothing in standard vector that does not have to be a member function. No function is there that shouldn't be in there. This is a good thing. And I believe this might help. This is something that Scott Myers proposed in, 2000, February 2000. An algorithm that helps you decide, should it be a free function, or should it be a member function? So, if f needs to be virtual, okay, obviously, for technical reason, it needs to be a member function. Else if the f is the output or input operator, or if f needs type conversion on its leftmost argument, then it should be a free function. It should be because else it doesn't work properly. If f needs access to non-public members of C, well, okay, this is true. If you need special access still, then make it a friend. This is reasonable. You still have the free function. It does have to be a free function, but it can access private data members. Else, if f can be implemented via C's public interface, okay, no question here. This is where the algorithm usually stops. If you do not have any reason to access private data members or private functionality, then there is no reason to make it a member function. So make it a non-member function. And else, if none of the other things apply, make it a member. And all the getters and setters are down here in the else part. And all the functions that truly need access, all these functions, of course, have to be member functions. So It is perfectly okay to use member functions. I'm not against member functions. All right. But I've learned the opposite. Right? So who has learned exactly the opposite? Who has learned that you should use member functions primarily? Okay, this is interesting, only a few hands. I would have expected this is almost everybody. However, this does not mean that the member function is truly the better choice. This just means that we have to definitely update how we teach C++. This is a general problem. This has been discussed many times over and over. How do I properly teach C++? Usually, the instructors have Java knowledge, so this was the time when I started C++. Yeah? Everybody knew about Java, and everybody was teaching Java just with C++ syntax. This is unfortunate. This is something, however, that you can help to change. You can spread this information. Hey, by the way, I've heard free functions are actually pretty cool, pretty powerful. Try to use them and spread the word. And so perhaps at some point, people in universities or wherever you learn programming actually hear the message. Free functions are the way to go. Okay. And there's a few people left. A few people who believe it's member functions. I'm still convinced it's member functions. And they come up with the ultimate argument. Free functions are just backward and C-style programming. Oh, I've heard this argument so many times. It's not really an argument, it's you know. Is it really? Are you convinced that this is backward and C-style programming? Okay. Let me just show you one thing. And perhaps this actually may make you think about this entirely differently. You know this function, I'm pretty sure about it. The copy function, std copy. Yeah? The copy function is pretty simple. I would even argue it's trivial. It contains a for loop and it does nothing but copy a couple of values. But this function actually adheres to, first of all, the single responsibility principle. It is one thing, it copies. It does nothing more. It does not allocate any memory. This is what it inherits kind of from memcopy. It also adheres to the open-close principle. This function never has to be adapted. Never. If you want something to be copyable, you just have to adapt your type accordingly. This function is sealed. This is good. I have to add stuff in order to make this work. It also adheres to the interface segregation principle. The name does not really give it away, but this is templates. There's no interface, but there's concepts. And the concepts in the copy function minimize the semantic requirements on your type. It's truly the minimum amount of operations that you need to provide in order to be able to use copy. This is adhering to the interface segregation principle. And, last but not least, this also adheres to the dependency inversion principle. It does because it owns its own concepts. It defines what operation you need to provide in order to work. I know, this is a little hard to get. This is probably something that you have to ask me afterwards, but this actually works too. So this simple, this trivial function adheres to 4 of the 5 solid principles, the basic object-oriented design principles. There's only one missing, the Liskov substitution principle. It cannot adhere to this principle because it's a function. Liskov is about types. But you and your type, you can adhere to the Liskov substitution principle if you provide an input iterator or an output iterator. Now you have to adhere to some behavior, expected behavior, in order to make this work. Now you should be impressed. Now you should be impressed because now perhaps you understand why the STL works so splendidly, why it's so awesome, and why Scott Myers, among others, said something like, there was never any question that the standard template library represented a breakthrough in efficient and extensible design. It is a different kind of object-oriented programming if you just see this as adhering to object-oriented principles. This is why it works so well. This is why it's so amazing. And so, this is not an argument. I don't get it, or I don't believe it. So, By now everybody's convinced. There's no more arguments. Nobody here has anything more to say. And you surrender. Okay, I will use free functions from now on. And the hypothesis, it becomes your new guideline. Prefer free functions, prefer non-member, non-friend functions. Okay, perhaps it's not your guideline now, but at least you have gotten a little idea that there is actually some value. So if you, until now, had only member functions, give free functions a chance. They might actually improve the quality of your code. And so, to summarize, free your functions. Thank you very much. Right, there's a couple of time for a couple of questions. I know I've taken all the questions already, kind of.
You didn't mention about parking. You could have free functions as static functions in a class. I mean, sometimes to polluting the namespace. Could you mention anything about that?
So, the question is, should I park free functions in classes? Note then they are not free functions anymore, then they're member functions also, static member functions. This is sometimes the right thing to do, but I found it rarely the right thing to do. A better way is to have a namespace. A namespace saying, detail namespace, put the free function there. If you want it to be found, then it's probably not in a detailed namespace. If you don't want it to be found, it's in a detailed namespace. A found namespace is much more versatile in this context than static member functions. But it depends. I don't say I'm against member functions.
Okay, thank you.
Yeah.
Many of your arguments were very convincing. There's one thing that wasn't on your list, which is mockability. So if you want to test a function that uses one of the free functions, and you want to avoid those side effects in your test because it's slow or whatever, if I put that free function inside a class, even if that class has no members or anything, I can subclass it to mock that function. How would I do that with a free function?
So how to mock a free function? So technically, not really possible. That is true. This would be a counter-argument. However, I recommend the talk from Monday or Tuesday. There was a talk about mocking classes, mocking in C++. And this is not really a thing in C++. So there is other ways to do it in C++. This is more the Java world, I have to admit. In C++, there's other ways to design things. So mocking, sometimes yes, as I say, I'm not against member functions, I'm not against virtual functions. This is not what I want to convince you about. But you should have the problem very rarely.
Okay. Yeah. Thank you.
Okay.
So,
are you convinced?
Yeah, so what?
Are you convinced?
Yes.
Yes!
So I came to the motivation for using free functions a little bit different route. We have a large code base, and we had lots of member functions that were accessing the member data and modifying it. Therefore, it made it hard to put breakpoints where all the member data was getting modified. So that's another benefit, is you're limiting access to your member data, or modification access.
So, he says he had a large code base, and in his code base it was actually a benefit to use free functions because they could not access all the data members. And I'm very grateful for this argument. This is something that you cannot convince people about, that's hard to show, but this is actually true. This is what I also found. Yeah? So usually, even in a large code base, do not be afraid to use free functions. You might, in the end, actually benefit from them. So they will not break everything suddenly. Yeah.
And so another motivation along with that was lots of member functions. Well, those needed to be grouped into logical groupings. And so then those go into a namespace that's logical namespace, so subdivision.
Which is reasonable. So all the free functions went to namespace. Yeah. Okay.
So given that we don't have unified call syntax, an argument against using free functions is that if you have a chain of function invocations, it looks kind of ugly with all the parentheses, and it's hard to tell what's going on with free functions as opposed to something dot something dot something. Do you have anything to say about that?
Okay, this is of course pretty subjective. So many people feel, so the question was that chaining free functions looks ugly in comparison to chaining member function calls. Some people agree. I don't. I like the free functions. I think I got this point. There's a law of Demeter, which you might know, which means you should not have a long chain of calls. If this happens, there's another problem. And so you should not have this very often, hopefully. You should have perhaps two nested function calls. So free function 1, free function 2. There should not be a huge chain of calls. So I would argue there shouldn't be long chains at all.
Okay, thanks.
Yeah, please.
Okay. So you had mentioned wrapping virtual functions with free functions, but also the opposite works too, is you have your virtual functions call a free function.
Absolutely.
So then you don't have much code in your virtual function.
Absolutely. So this is actually something I'd really forgot. You can, of course, also call free functions from virtual functions. This is why type erasure works in the first place. This is the technique used in type erasure. Or it is one piece in the puzzle. This is actually possible too, and I recommend it because the free function can be very easily tested, and the virtual function suddenly does not have to be tested anymore because it's a simple function call. All right, this concludes the session. Thank you very much.